Hello everyone, welcome to our channel. In this video, I'm going to solve a problem which came in JAM Biotechnology paper in 2021. Now, before going to the solution, here is a very important information for you. If you are preparing for IIT JAM, then you must be preparing for other common university exams also, right? So here is a good news for you. Unacademy brings for you a batch course which is starting from 15th of March. That is from tomorrow. Here, top educators would teach you and the classes would be totally interactive. This will help you to prepare for the entrance exams of BHU, CUCET, etc. You can find the details in the description also. You can also use my code FISHJAM-570 for 10% discount to subscribe the plus classes. Okay, I'm repeating. You can also subscribe to plus classes using my code PHYSJAM-570 for 10% discount. Okay, so let's go back to our question. Here the question is, the velocity of blood in a blood vessel of 2.0 centimeter radius is 30 centimeter per second. When the blood vessel bifurcates into two smaller vessels of radius 1.0 centimeter each, the velocity of blood in each of the smaller vessels is dash centimeter per second. Assume that the vessel walls are rigid and blood is incompressible. Okay, so let's solve this question. Now, first of all, let me tell you these two words. The vessel walls are rigid and blood is incompressible. What these two words mean? These two words mean that if vessel walls are rigid, that means the vessel volume would not be changed, and if blood is incompressible, that means the volume of blood would not be changed. That means the uh, volume of vessel would be equal to the volume of blood. Okay, so we get from that the volume of blood. Okay, and here given first of all the radius of the blood vessel initially, that is, let us take it as r. So r equal 2.0 centimeter. Okay, and the velocity of blood is given as 30 centimeter per second. Okay, so let us take it as velocity of blood, let us take it as u. Okay, so u equal 30 centimeter per second. Now you may wonder why I am taking it as u. You can understand it later. Now, after that, the blood vessel bifurcates into two smaller vessels of radius 1.0 centimeter each. Okay, so let us take it as R1. Okay, so R1 equal 1.0 centimeter, and the velocity of blood in each of the smaller vessels we need to find. Okay, that means we need to find u1. Okay, we don't know u1. Okay, now what is the formula to finding to solve this kind of problems? What is the formula of blood flow? Okay, that is the rate of flow. Suppose Q is the rate of flow, then Q is equal to A, that is the area of the vessel, blood vessel, times V. Now this should be U in case of our our problem, that is u is velocity. Okay, now let me write this down. That is rate of flow is equal area into u is velocity. Now you may ask that from where we get this formula, right? Rate of flow is equal area of velocity. Now let us first understand if we can deduce this formula or not. Okay, suppose this is the blood vessel, okay, which bifurcates into two smaller blood vessels. Okay, suppose this is the one. Okay, my drawing is very bad, so please forgive me. Now see, when blood is flowing through it, okay, so what is the rate of flow of blood? Okay, it is also true for water, rate of flow of water through pipes, okay, and similar kind of things. Okay, so we can say rate of flow of blood, that is q, we can take it as q. So q is equal volume of blood divided by unit time. So in unit time, the amount of blood flowing through this pipe or vessel, okay, flowing through this vessel, it is the rate of flow, right? That is volume of blood divided by unit time. Okay, so q equal volume by time. Here this v is volume of blood, okay, volume of blood by unit time. Okay, so we can write it as v by t, right? This v is volume, don't be confused. This is why we have taken u as the velocity, okay, u as the velocity and v as the volume. So q equal volume by time, that is v by t. Now for volume, for calculating the volume, we can write that is volume is equal to the area of cross-sectional area of the vessel times the distance. Okay, suppose this is d, okay, this is the length of the, suppose this is the larger vessel, okay, where d is the length of the vessel and a is the area of cross section of the vessel, okay, like this. So this area is a, we have taken it as a, and d is the distance or length of the vessel, okay, or the distance of blood flowing through this vessel. Okay, so we can write v equal a into d by t, right? That is volume equal area into distance or area into length, right? So a into d by t. Now see here, this d by t, what it means? Distance per unit time, right? Distance per unit time is actually velocity, right? So we can write it as a into u, because our u was the velocity, u equal d by t, right? So this is the velocity of blood through this vessel, velocity of, sorry, let me correct it. So it is velocity of blood through this vessel. Okay, U. So A into U, that is rate of flow of blood is equal area into velocity. This was our formula. Rate of flow of blood equal area of the vessel times velocity of blood in the vessel. So now we can use Q equal A into U. Okay, this is true for the larger vessel, right? The initial vessel, blood vessel. Now, when it bifurcates into two smaller vessels, that means Q, we can write, if it is Q initially, then Q is equal to Q1 plus Q2, right? How it becomes? You can get it from this analysis. If you cannot get it, if you cannot understand how I take Q equal Q1 plus Q2, that is the rate of flow in the smaller vessels. Okay, now here, as the the radius of the two vessels are equal, just equal, that means we can take Q1 and Q2 equal, Q1 equal Q2 in our case. Okay, that means we can write it as, if Q1 equal Q2 equal Q, say, so we can write it as Q equal 2 small q. Okay, capital Q equal 2 small q, where small q, this small q is the rate of flow through the smaller vessels, smaller blood vessels. Okay, if you don't understand this, you can tell me in the comment section. I would love to explain this for you again. Okay, so I hope you can understand how capital Q is equals to small q. Okay, so if it is true, that is Q equal capital Q equal to small q, then we can write, see, Q is equal R1 into U1, right? That is small q. Small q equal R1 into, sorry, it is not R1. Sorry. We can take it as A1 into U1. That is, A1 is the area of the smaller vessels. Now, what is the area of the smaller vessels? Area of the smaller vessels is A1 equal pi R1 square, because they are cylindrical vessels, right? We can assume the blood vessels to be cylindrical, right? So if cylindrical, then the area of the cross section of the vessels would be pi R square, that is pi R1 square. And similarly for this capital A, that is the area of the larger vessel, the initial vessel was A equal pi R square, this R, right? So we can now use this, okay, that is, we can write Q equal, capital Q equal to small q, that is 2, that is capital Q. In case of capital Q, we can use A times U. Okay, capital A times U, that is equal to small a times A1 times U1, right? Now in case of A, we can use this pi R square. So pi R square times U equal to A1, that is pi R1 square. So pi R1 square times U1. Right now from two sides pi cancels out and we get R square U equal to R1 square U1, and we need U1, right? We need this u1. So we can take u1 equal r square u by 2 r1 square. Right now, what is r square? R is 2.0 centimeter. So 2 square into u is 30 centimeter per second. So 30 divided by 2 into r1. What is r1? It is 1.0 centimeter. So it is 1 square. Okay, remember one thing here, that is all of the given quantities are in CGS unit. See, all are in centimeter or centimeter per second. So we don't need any conversion, any unit conversion, right? From SI to CGS or CGS to SI. But in the further questions in your exam, you can have the units to be mixed systems, right? So remember to convert them. Okay, now now this 2 and this 2 square, that is 4, cancels out and we get 2 times 30, right? It was 4 times 30 by 2, that is 2 into 30, that is equal 60, and the unit would be centimeter per second because all are in CGS. So we get centimeter per second. So the answer is 60 centimeter per second, and our answer also needs in centimeter per second. So the answer is 60. So 60 centimeter per second is our answer. I hope you could understand this solution. If you have any doubt regarding this solution, you can tell me in the comment section. If you like this video, please click on the like button, share this video with your friends, and if you are a new viewer today, then don't forget to subscribe our channel. Tata!